In this lecture, we are going to compare arrays versus linked lists and find out which is more efficient in terms of computing. As you may already know, array is a linear data structure which enables quick random access to its element based on indexing. Linked list is also a linear data structure. However, it is composed of nodes, where each node has a reference to a next or previous node. Therefore, access to a certain element requires a linear search. Arrays are distributed dense and physically next to each other on computer memory, whereas linked lists are distributed sparsely and not necessarily next to each other. Further, in the lecture we will see the difference in distribution on computer memory of these data structures is crucial for their performance. Let's talk about time complexity of basic operations of these two data structures. Adding to the end of the sequence in both array and linked list takes constant time. Accessing a certain element in the array also takes constant time, while the same operation in a linked list opts for linear time. This is due to linked list does not have a random access. Insertion in both array and linked list cases takes linear time, but this is due to different reasons. When inserting in an array, we have to shift the remaining elements to keep it in order, and in the case of a linked list insertion is simpler. But the search of an insertion spot takes a linear time. In terms of deletion, everything is the same and for the same reasons. The search in both mentioned data structures takes linear time. Both data structures have their advantages and disadvantages. One may ask which of these is better. To answer the question, we might solve the following problem. Let's say we have generated n random integer numbers and we need to insert them one by one in the right position so that the sequence of the numbers would be sorted. Next, we need to remove these numbers from random positions till our sequence is empty. These operations must be performed using array and linked list, and computation time must be measured by both data structures. This solution should help us to answer what n linked list performs faster than array or vice versa. In order to solve this task, we have to execute the following subtasks. First, we need to generate the sequence of n random integers. Second, generate the n random positions of deletion. Next, we need to insert the generated integer numbers in a sorted sequence. In case of dynamic array, the insertion will take quadratic time complexity since our algorithm first will find the right spot to insert, then it will shift the remaining elements of the array. We could optimize this part by using binary search or shift the elements at the same time as we search for the insertion position, but let's just leave this part as it is. In case of doubly linked list, time complexity of the insertion subtask is linear, since we use linear search for the insertion spot and then simply insert the element at a constant time. Finally, we need to remove these numbers based on generated deletion sequence. Here, both data structures have the same time complexity, which is linear. Dynamic array is linear due to shifting operation, and doubly linked list is linear due to linear search. To find out which data structure performs better, we need to measure the execution time of the insertion and deletion subtasks using both dynamic array and doubly linked list. Okay, let's run our solution. I have implemented the solution using Java programming language. First, let's start our benchmark. And now let's let's discuss what this code does. In our main function, we have a function called benchmark, which is used for benchmarking with different numbers of integers. Let's look at the benchmark method. First of all, we generate random numbers and deletion indexes. We are not going into details on these two functions since it is not relevant in this case. Then we create an array. For an array implementation, we use Java ArrayList, which is a dynamic array. Also, we have two methods, add and remove. We take the start timestamp before the main calculations. And then we add our generated elements one by one into dynamic array. Next, we remove the elements one by one till our array is empty. Then we can take the timestamp of the calculation. We do the same for a linked list. In this implementation, we have class named list. Here we use Java linked list, which is implemented as doubly linked list. And we have add and remove methods. The remaining calculations are identical to calculations performed using dynamic array. The last code lines are for printing the execution time results into console. Let's look at our benchmark results. As we can see, the dynamic array beats doubly linked list at each n. The bigger the n is, the greater the difference of the execution time. Remember that the time complexity of dynamic array insertion implementation was even worse compared to linked list insertion implementation. But our benchmark results show the opposite results. So the main question is why? To answer this question, we need to remember how linked lists and arrays are stored on computer memory. Linked list is sparsely distributed on it. This kind of distribution increases the possibility of cache misses, while in case of array, it is possible to cache the data more efficiently. Cache memory is limited but very fast. If we have the greatest part of our data structure stored in it, the operations will be significantly faster compared to computer memory, which is slower, and additional operations are required to load the data to CPU registers. The subsidiary reason of array being faster than linked list is that array shifting operations, which dominate when inserting and deleting from array, are optimized on a low level. The key points of this lecture would be the following. Array-based and pointer-based data structures are fundamental building blocks of other more complex data structures. Dynamic array is a linear data structure which enables random access due to dense and orderly memory distribution. Linked list is a linear data structure which has sparse memory distribution. In linked list, element can be accessed by iterating from the start to the end of the list. The deletion and insertion in linked list is simpler compared to dynamic array, although in most of the case, the line search is required to find the right spot for insertion or deletion. The deletion and insertion in dynamic array requires element shifting, which takes O(n) time. Nevertheless, the dynamic array shift operation is implemented at a low level and is very fast. The sparse memory distribution of linked list increases, a cache misses, whereas array can be cached more efficiently. Therefore, dynamic array is a primary choice for list implementation. Thank you for your attention.